NASA's strategic initiative deploying a small modular nuclear reactor on the moon by 2030. Acting NASA Administrator Sean Duffy recently announced an accelerated plan to develop and deploy a high-output nuclear fission reactor on the moon, aiming to have it operational by 2030. This project is part of the Artemis program and focuses on providing a reliable, continuous power source to support long-term human presence and extensive scientific activities on the lunar surface. The reactor will utilize small modular reactor technology designed to produce at least 100 kilowatts of electric power, enough to meet the basic energy needs of a lunar habitat housing 4 or more astronauts. This represents a significant step forward from earlier designs and marks NASA's move beyond radioisotope thermoelectric generators, RTGs, toward full-scale nuclear fission power in space. This initiative comes amid growing geopolitical competition, especially with China and Russia, both of which have announced plans to build nuclear reactors on the moon by the mid-2030s. These developments present strategic challenges, particularly over control of the lunar South Pole, a region known for its near-constant sunlight and permanently shadowed craters rich in valuable resources like water ice, essential for in-situ resource utilization, ISRU. Duffy warned that the first country to deploy such infrastructure might declare keep-out zones, limiting U.S. access to these critical areas. This directive is a proactive step to protect U.S. interests and maintain leadership in extraterrestrial resource development. The reactor design incorporates advances in compact fission technology, including strong radiation shielding, heat rejection systems adapted for the vacuum of space, and autonomous operation to minimize astronaut exposure. Unlike reactors on Earth, lunar reactors will dissipate waste heat through radiative panels since there's no atmosphere for convective cooling. NASA has been researching fission surface power since the early 2000s, partnering with aerospace leaders like Lockheed Martin and Westinghouse for prototype development. By 2025, these prototypes have matured enough that NASA is now seeking industry input within 60 days to finalize a launch-ready system. However, this ambitious nuclear project comes at a time of significant budget constraints. The FY26 NASA budget proposal cuts funding by 24.3%, forcing the agency to prioritize crewed exploration missions while scaling back planetary science and climate research. The Artemis program has already faced delays due to technical issues with the Space Launch System, SLS rocket, and Orion capsule, compounded by supply chain disruptions. The lunar environment itself poses unique energy challenges. The moon's day-night cycle lasts about 29.5 Earth days, meaning long stretches of darkness where solar panels become ineffective without massive energy storage solutions. In permanently shadowed regions near the South Pole, where temperatures can drop to minus 230 Celsius, solar power is essentially unusable. A nuclear fission reactor offers continuous, reliable power to support critical systems such as life support, habitat climate control, electric vehicle charging, and ESRU operations like extracting oxygen and hydrogen from lunar ice. The high energy density of uranium allows significant power output with relatively low mass, a key advantage for transporting equipment to the moon. To ensure safety, lunar reactors must manage heat through radiative cooling, detect faults autonomously, and include robust shielding to protect crew and instruments from radiation. NASA plans to bury or shield the reactors beneath lunar soil to further reduce risks. Deploying a nuclear reactor on the moon is expected to accelerate developments in lunar infrastructure, enable propellant production for Mars missions, and support off-world industrial activities. In summary, NASA's push for a lunar nuclear reactor represents a strategic investment in securing reliable energy for sustained lunar exploration, reinforcing U.S. leadership amid increasing global competition. As Administrator Duffy put it simply, to have a base on the moon, we need energy.